So we're squared away on multiplication and division of fractions now, and that leaves addition and subtraction, which I think are the two that quite often just throw students for a loop. And I'm really going to ask you to bear with me here, okay? I have an easier way to add and subtract fractions than what you were probably taught all the way back in middle school. So just kind of bear with me here, and hopefully this will ease your mind a little bit. So let's say we want to add 1/5 plus 3/5. Well, the distinguishing feature that you need to spot with this one is that the denominators are the same. Right, so you can take that same concrete interpretation that I've used in examples in the previous lectures here and say, look, well, this is saying 1/5 plus 3/5. Literally think of those fifths as objects. If I have 1/5 of something and I have 3/5 of something and I combine them together, well, I'm going to have 4/5. Right? And I talked about it in a previous lecture. If this is too abstract for your students, try doing it with apples. If you have 1 apple plus 3 apples, how many apples do you have? Well, then it's obvious, right? You've got 4. Well, replace apple with fifths. Right? Replace apple with fifths, and you get this exact same result here. Right? You end up with 4/5. Okay. So what do we do if the denominators aren't the same? Well, you got to make them the same at the end of the day. And this is where the trouble starts for a lot of students. And I realize I am going to offend a whole generation of middle school math teachers with what I'm about to say here. But you do not have to find the least common denominator to add two fractions together. You simply don't. Right? And I hate that the teachers tell students you do. Because now, in addition to this addition problem, now before you can do this, you have to go off to the side. You have to remember the process we talked about a few lectures back about finding the least common multiple. You have to do prime factorizations and remember, do I use all the factors or just some? Look, you don't have to do that. You just don't. The rule is the two fractions have to have a common denominator. It doesn't have to be the least one. Any common denominator will do. Right? So here's what I'm going to do. I'm going to take the top and bottom of the first fraction, multiply it by the denominator of the second one. Right? The denominator of 4/5 is 5, so I did 2 times 5 and 3 times 5. Kind of cross the denominator over to the other fraction. Now I'm going to do the same thing going the other way. I'm going to take the 3, that's the denominator of the first fraction, multiply the top and bottom of the second one by it. Right? So 4 times 3 over 5 times 3. Now look at what happened. Look at the denominators. 5 times 3, that's 15 on both sides. So now we have 10 15ths plus 12 15ths. The denominators are the same. Add the tops together. 10 plus 12 is 22. 10 15ths plus 12 15ths. 10 apples plus 12 apples. At the end, you got 22 of them. Simple, right? Okay, now, yes, okay, 15 was, in fact, the least common denominator here. So just to convince you that this works, now let's take a look at another example here. If you look at this and see, oh, hey, look, 4 and 12. 4 times 3 is 12. I can just multiply the top and bottom of the first fraction by 3. I got my common denominator. I'm home free. If you see that, awesome. Absolutely, it works. Right? If you don't see that, then my method here is going to work absolutely just fine. Right? So I'm going to start by multiplying the top and bottom of the first fraction by 12, the denominator of the second one. I'm going to multiply the top and bottom of the second fraction by 4. That's the denominator of the first one. And I get this thing here, 1 times 12 over 4 times 12, minus 5 times 4 over 12 times 4. Multiply everything out. Hey, look, the denominators are the same. Okay, and now you notice this is a subtraction one instead of addition. Right? It's going to work the same way. Right? When you're adding, you add the two numerators. When you're subtracting, you subtract them. 12 minus 20, that's negative 8. 48 stays the same. And we're not quite done. Right? Now, with the last one, that fraction was already reduced. I didn't explicitly mention it, but it was already reduced. Here it's not. I can divide the top and bottom of this thing by 8. Right? 8 goes into 8 and 48. So 8 divided by 8 is 1. 48 divided by 8 is 6. There's my final answer, negative 1/6. Okay, now at this point, I've occasionally explained this to teachers and had them come back with various complaints. And the most common was, well, but you may have to reduce the fraction here where you might not have if you had found the least common denominator. And yeah, there's some truth to that, but it's not a guarantee. I mean, take a look at this problem here. If we had gone with 12 instead of 48, you still would have had to reduce the fraction at the end. Right? How do I know that? Well, if we use 12 as the common denominator, when we get to the end, 12 is going to be the denominator. Obviously, that's not the final answer because you can see right here that the final denominator is going to be 6. So, yeah, you may have to reduce this way. You may have to reduce the old school way. Doesn't matter. To me, it's worth it. Right? To me, maybe reducing is easier than doing that whole least common multiple prime factorization nonsense. Right? So, yeah, I'll take having to do a little extra reducing over the alternative any day. Okay, so that's the end of our discussion of arithmetic with fractions. In the next lecture, we're going to talk about fractions versus decimals. Right? They're both different ways of representing the same kinds of quantities. Right? So we're going to look at ways for switching back and forth between the two forms.